Okay, what if I told you that the common screw, that little piece of tech we've been using for literally thousands of years, could actually be on its way out? Today, we are diving deep into a really cool patented invention that completely ditches the screwdriver for a single, super fast pulse of fluid.
So here's the game plan for this explainer. First up, we'll get into why we even need a replacement for the screw in the first place. Then we'll check out this fluid-powered solution and really dig into how it works on the inside. After that, we'll see where it's being used first, think aerospace. And finally, we'll dream a little about what this could mean for the future of, well, putting anything together.
All right, so let's kick things off with a problem that I'm pretty sure every single one of us has dealt with. Yep, we're talking about the simple, humble, and, oh man, sometimes incredibly frustrating screw. I mean, we've all been there, right? You're fumbling around for the right screwdriver, you strip the head, or you just spend way too long on what should have been a 5-minute job. Now, that's annoying when you're just putting together some furniture, but imagine that in a high-stakes industry. It becomes a huge problem.
Just take a look at the aerospace world, for example. A maintenance tech might have to pop off a panel like this one, and it's held in place by dozens, maybe even hundreds of these little fasteners, and every single one has to be taken out one by one. That's not just slow, folks. That's a massive hit to the bottom line. So when you really break it down, what are the hidden costs? Well, you've got the sheer amount of time that's wasted, you've got the need for a whole toolbox full of different drivers and wrenches, there's always the risk of a screw seizing up from corrosion or stripping the head because you used too much force. But you know what the biggest killer is? It's that you have to do it all one at a time. It's totally sequential, and that just multiplies the time and effort.
But what if? What if you could just deal with all of those fasteners at the exact same time? Well, that's the big idea behind this invention, which is all laid out in this German patent. And look, this isn't just some idea scribbled on a napkin. This is a fully granted patent, number 10, 2013, 184-2 to be exact, from the German Patent and Trademark Office. The inventor, Jacques Chuango, basically laid out a whole new way of thinking about how we attach one thing to another. So what are we actually talking about here? Well, at its heart, it's a fastener that's operated remotely using fluid. Think about that. Instead of a screwdriver, you use a quick pulse of something like compressed air to lock or unlock it, and it happens instantly. The key thing to get here is that you don't need to touch the fastener itself with a tool at all. Okay, that sounds awesome in theory, but how does it actually work? Let's peel back the layers and get right inside the mechanism. So the patent lays out two main ways to get this done. There's a radial design, which is kind of like a pushpin, and then there's a rotational one, which acts a lot more like a regular screw. Okay, first up is that radial design. So when it's locked, you can see these little pins are pushed out. They grab onto a groove in the material and hold everything super tight. Now to unlock it, you've got to get those pins to pull back in. And here is where the magic happens. A single blast of fluid pressure hits a cylinder inside the fastener. Just watch. It pulls those locking pins in, and damn! The whole thing is released instantly. It's just a really simple, elegant, and incredibly fast little piece of engineering. All right, now for design number 2, the rotational one. This one looks a lot more familiar because it has a regular thread. But here's the twist. Instead of a spot for a screwdriver, the head contains a tiny little motor that's powered by fluid. So let's watch this one go. When fluid gets pushed through that head, it spins a tiny little rotor inside. That rotor is connected right to the threaded part, and it gives it all the torque it needs to screw in or out at high speed. The power isn't coming from your wrist, it's coming from the fluid. So, okay, we've got this absolutely amazing core technology, but a great idea is only as good as its application, right? So where do you start? Let's follow the journey from a patent drawing to an actual real-world product. And this is where it all gets real. We're moving from those black and white technical drawings to a slick, polished product that's built for one of the toughest industries on the planet, aerospace. So, why aircraft cabins? Well, for one, they are just jam-packed with panels that need to be opened all the time for maintenance. This tech means you can get in and out super fast, which slashes maintenance time. It also makes the whole job simpler, because you're not juggling a bunch of different tools. And, this is a big one, it's all pneumatic. It's just powered by air. So you're not adding any heavy or complex electrical systems into the mix. And this, right here, this is the real game changer. The genius isn't just replacing one screw, it's about creating an entire system. You can see in this schematic how you can link dozens of these things together with some simple tubes, and they all run back to one single spot where you can control them all. I mean, this quote from the inventor's pitch just nails it. We're talking about a step change in productivity. It means dramatically faster maintenance and much safer access, especially when you're working in a tight spot where trying to use a regular tool is a real pain or even dangerous. Now, aerospace is a fantastic place to start, for sure. But the potential for this kind of technology goes way, way beyond just airplanes. This could be about the future of how we build, well, everything. Just think about it for a second. What about modular construction where you could pop walls up or take them down in minutes? Or industrial machinery that you can service in a fraction of the time? Think about assembly lines for cars or electronics suddenly becoming way more efficient. This isn't just one product. It's a platform technology. You could use it almost anywhere we're using a screw today. So that kind of leaves us with one big question to chew on. We've used screws for thousands of years for one simple reason. They work. But this technology really forces us to think differently about the whole idea of assembly. We're talking about a huge shift from a slow, manual, one-by-one process to something that's instant, parallel, and automated. So I'll leave you with this. What would you build if you never had to turn a screw again?